Hello everybody. Hey, do you ever wonder when we're flying this aircraft out in the atmosphere, we're going to need data to help us control this airplane. For example, how fast are we going? What's our altitude? What's our rate of climb and descent? And I want you to think about that as air data, data from the atmosphere about this aircraft operating in the atmosphere. Well, guess what? We get that through the Pitot-Static System. Hello everybody, welcome back to the Epic Flight Academy. I'm Mike Thompson and this is the instrument rating course. Now remember, to be successful in the course, you are studying Epic's online material and referencing and referring to all of the resources in that material. Number two, you're here watching these videos in parallel to that content, and boy, we're glad you're here. Number three, we want you to review all of this material with your flight instructor. So what about this air data? What about this Pitot-Static System? Yes, that's what the Pitot-Static System does. And if you take a look at the diagram behind me, you can see that the Pitot-Static System takes atmospheric inputs to 3 instruments specifically. Now, we have gone over this system and these instruments in the private pilot course, and you can link back to earlier videos and review that material. What we want to do here in the instrument rating course is just cover some information on this system and instruments specific to instrument pilots. So let's get started. Now, we can see that we have a pitot tube going to the airspeed indicator and the static air going to all 3 of our instruments. Now that we know. As an instrument pilot, what I want to call your attention to is in the pitot tube itself, we have both ram air pressure and static air pressure. So a little deeper understanding of the pitot tube. The actual airspeed indication is the difference between the ambient air pressure, static air, and the ram air pressure coming into that pitot tube. And you can see that depicted here. You can see the pressure chamber and the static chamber. Remember, the difference is what gives me indicated airspeed. Now, on this slide, we wanted to go back and look at the altimeter in just a little bit more detail. And what I want you to notice here is when we're flying on instruments, the altimeter in the airplane must be what we refer to as a pressure-sensitive altimeter. Well, aren't all altimeters sensitive to pressure? That's what makes them an altimeter? Yes, but what we mean by pressure-sensitive is specifically this altimeter must have a method to allow the pilot to adjust the altimeter setting in the Colesman window. And you can see that altimeter here. So this sensitive altimeter allows the pilot to adjust the altimeter setting. Now, on our next slide, we're looking at types of altitude. Now, I'm not going to go through these types of altitude in detail. Why? Because we have talked about these types of altitude in detail in earlier videos. Just remember, indicated, pressure, density, true, and absolute. They are all distinctly different, so be sure to review that content. Then we get to the vertical speed indicator. Now, again, we looked at that in pretty good detail in the private pilot course, but as an instrument pilot, we just want to review and be sure we understand that the static air source in this instrument goes directly into that diaphragm. And the case of the instrument is vented to static air. Now that case is vented through what we call this little calibrated leak. And what that means is as this instrument moves up or down in the atmosphere, that static air comes directly into the diaphragm, and there's a little delay between the equalization of the pressure in the diaphragm and the case, and that difference is my vertical speed, either up or down. So review that also with your flight instructor. Now, the airspeed indicator, again, you see that on the screen here. There's not much here for the instrument rating that we have not already discussed in pretty good detail in an earlier video. So you can link back to that airspeed instrument video. Now, don't forget, just like altitude, there are different types of airspeed. Once again, we have reviewed these, so I won't go into them in detail. Just to remind you, iced tea is a pretty cool drink. The indicated airspeed corrected for, what's it corrected for? That's it. The position error and any little instrument errors gives me, what does it give me? Calibrated airspeed. That's right. Calibrated airspeed corrected for compressibility gives me equivalent. Equivalent corrected for density. Remember, that's both pressure and temperature, gives me true. So those are my different types of airspeed. Refer back to an earlier video. Now, we also talked about some pitot-static errors and blockages. Now, in the private pilot course, we touched on those briefly. As an instrument-rated pilot, this information is going to be critical to us because should we experience any of these blockages or errors and we are IMC in the clouds, that could be potentially hazardous unless we are proficient in the operation of the airplane and understand this pitot-static system in detail. So let's take a look in a little more detail at some of these errors. Now, in order to do that, I want to use this chart right here. Now, notice in the left-hand column, it talks about the failure. So let's just say, for example, the pitot tube itself were blocked. And we can see what effect would it have on the altimeter? Well, none. The altimeter doesn't use pitot tube input. What effect would it have on the airspeed indicator? Now it would have some effect. That ram air pressure would no longer be coming to the airspeed indicator, and if the vent hole on that pitot tube were also blocked, the airspeed would start to act like an altimeter because the air is trapped inside that diaphragm in that airspeed indicator while the case is still vented through the static system. And what effect would that pitot tube block have on the VSI? You're right, none. The VSI doesn't use it. Now, take a look going down the left-hand column. If one static source were blocked, what effect on the altimeter? It would be inaccurate if we were to slip or skid the airplane. The airspeed, same thing, inaccurate, slipping and skidding. VSI, same thing. Coming down the left-hand column, let's look at our third error. If both static sources were blocked, now the altimeter doesn't change with altitude. If it blocked off before takeoff, it's going to indicate field elevation throughout the flight. Or if it blocked off, both of them blocked off in flight, it would just lock in at that altitude and just indicate that altitude. The airspeed indicator would decrease during a climb and increase during a descent. The VSI indicates the last vertical speed before becoming blocked. And then finally, our last error, all static and pitot sources are blocked. If that were to occur, the effect on the altimeter would be its indication remains constant regardless of any change. The same would be true for the airspeed indicator, and the same would be true for the VSI. So these pitot-static errors, we want to know in a little more detail as instrument-rated pilots. Please review that in the Instrument Flying Handbook and with your flight instructor. Well, folks, that is our review of pitot-static for the instrument rating. We'll see you next time.